Hello and welcome to Solve, the virtual lab at NITK. This is the experiment to determine the natural frequency of a simple pendulum whose length can be varied to provide various initial parameters for students to work out. The possibility of variation in length of the pendulum offers a great opportunity to students to perform the experiment with new conditions every time they indulge in it. This innovativeness adds that essential bit of newness to the experiment. But how do we do it?
In this experimental setup, there consists of a simple pendulum wherein the rod of the pendulum is a prismatic joint with the inner rod connected to the thread wound over a pulley which is driven by DC motor. The outer rod is also connected to a bob which will be oscillating when disturbed from its state of rest.
To make the experiment technically feasible, it is equipped with proficient circuitry. Let's see what are they and how they coordinate. The system comprises of a couple of actuators in the form of DC motors and couple of sensors in the form of rotary encoders. The bottom encoder is responsible for sensing the angle of rotation, which is actuated by the DC motor at the bottom. The upper encoder measures the length of the pendulum as specified by the user while conducting the experiment. The length variation of the pendulum is achieved by the upper DC motor, and all these components are compactly mounted on the top. With the help of the interface, I will explain you how actually to conduct the experiment, and you'll also see what happens when you give certain commands over internet. In this screen, the first step you need to do is to change the length of the pendulum by moving the slider. Once you set the length, click on Change Length. You can see the value changing at current length position. Then you actuate the pendulum by clicking here. You can have total 3 trials if you want to, but if you are good with your acquisition, save the data onto your computer and then stop the data acquisition. Once the data acquisition is done, the amplitude of oscillation can be seen on the screen. Now click Next, and that will take you to the page where you can use the cursor to find out the peak values of the oscillation. Note down the cursor values of X. Now, with the formula given in your reference theory page, calculate the observed and theoretical frequency. Once you have these values, enter in the respective slots and proceed ahead by clicking Submit. Say yes. Press Next, and that will take you to the last page where you have your results tabulated. If you'd like to have the result table for future reference, save the result onto your computer and say Exit. If you want to redo the experiment with changed parameters, go ahead and change the length and repeat the steps for a new set of values to work with. Thank you for conducting the experiment, and we hope you will come back again.